Hello friends, welcome to my channel Eccentric Learning. Many videos on various quantitative aptitude topics like polynomials, quadratic equation, coordinate geometry, etc. has already been uploaded. I hope you guys are going through that. If not, some of the videos link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we'll be seeing some of the algebraic formulas and rules pertaining to numbers which are in the form of a raised to power n plus minus b raised to power n. And in the next video, we'll be doing some questions based on these formulas and rules. So let us start with today's video. First, let us see some of the algebraic formulas. A plus b whole square, which simply means a plus b times of a plus b. And when we expand this, this would be a square plus 2ab plus b square. In a similar way, a minus b whole square is a minus b times of a minus b. And when we expand that, it would be a square minus 2ab plus b square. In a similar way, a plus b whole cube is a plus b times of a plus b times of a plus b. And when we expand, then the formula would be a cube plus 3ab times of a plus b plus b cube. And this can also be written as a cube plus 3a square b plus 3ab square plus b cube. In a similar way, a minus b whole cube can be written as a cube minus 3ab times of a minus b cube, which can further be written as a cube minus 3a square b plus 3ab square minus b cube. Now, from the third and the fourth formula, we can derive the formula for a cube plus b cube and a cube minus b cube. So first, from the third one, we know a plus b whole cube is a cube plus 3ab times of a plus b cube. So if we write a cube plus b cube and if we take 3ab into a plus b to the left hand side, in that case, this would be a plus b whole cube minus 3ab times of a plus b. Now, if we take common a plus b, in that case, we would be left with a plus b whole square, which would be a square plus b square plus 2ab. And in this, we'd be left with minus 3ab. So this would be finally a plus b times of a square plus 2ab and minus 3ab would be giving us minus ab, and this is plus b square. So from here, we can get the formula for a cube plus b cube, which is simply a plus b times of a square minus ab plus b square. In a similar way, from the fourth one, we can derive the formula for a cube minus b cube, which would be given by a cube minus b cube as a minus b times of a square plus ab plus b square. Since a cube plus b cube is given by a plus b times of a square minus ab plus b square, so we can say that a plus b would be a factor of a cube plus b cube. In a similar way, a minus b would be a factor of a cube minus b cube. Now, let us see the formula for a plus b plus c whole square and a cube plus b cube plus c cube minus 3abc. A plus b plus c whole square is simply a plus b plus c times of a plus b plus c. Now, when we expand this, we'd be getting a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Also, a cube plus b cube plus c cube minus 3abc is given by a plus b plus c times of a square plus b square plus c square minus ab minus bc minus ca. Because when we expand these two factors, we'd be getting a cube plus b cube plus c cube minus 3abc. So, a cube plus b cube plus c cube minus 3abc can be written in this way. Now, let us see how we can make the use of this formula. Suppose if a has been given as say 43, b has been given as say 27, and c has been given as say minus 70, and we need to find the value of a cube plus b cube plus c cube. Well, one thing that we can do is we can find the cube of 43, cube of 27, and cube of minus 70, and we can add them all. But that would be too much time consuming. So instead of that, what we can do, we can simply take the help of this formula. Well, here, if you look carefully, A plus B plus C value would be simply 43 plus 27 minus 70, which is nothing but 0. And in this formula, if this part is 0, so we can say that the right hand side would be 0. So a cube plus b cube plus c cube can be directly written as 3 times of ABC. So this would be simply 3 times of 43 times of 27 times of minus 70. And when we simplify this out, this would be minus 243,810. So instead of finding the cube and then adding them up, what we can do directly is we can simply use this formula. That is, if a plus b plus c is 0, in that case, a cube plus b cube plus c cube would be given by 3 times of ABC. Also, there is one more way by which a cube plus b cube plus c cube minus 3ABC is written, which is simply half of a plus b plus c times of a minus b whole square plus b minus c whole square plus c minus a whole square. Well, this form we are getting simply by multiplying 2 in this factor and taking 1 by 2 outside. Because this would be in that case 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca, which can be written as a minus b whole square plus b minus c whole square plus c minus a whole square. So I would also suggest you to remember the formula of a cube plus b cube plus c cube minus 3abc in this form as well, as it would be very handy sometimes to get to the answers easily. Now, let us see some rules which we can apply when numbers are in the form of a raised to power n plus b raised to power n or a raised to power n minus b raised to power n, where the small n belongs to natural number. We know a square minus b square is given by a plus b times of a minus b. So we can say that a minus b is a factor of a square minus b square, or in other words, we can say that a square minus b square would be completely divisible by a minus b. In a similar way, a cube minus b cube is given by a minus b times of a square plus ab plus b square. So here also a minus b is a factor, or we can say that a cube minus b cube would be completely divisible by a minus b. Now, if we go for a raised to power 4 minus b raised to power 4, which can be written as a square plus b square times of a square minus b square, which can further be written as a square plus b square times of a plus b times of a minus b, because a square minus b square is a plus b times of a minus b. So when a is raised to power 4 and b is also raised to power 4, in that case a raised to power 4 minus b raised to power 4 will also have a factor of a minus b. Or in other words, a raised to power 4 minus b raised to power 4 is completely divisible by a minus b. In a similar way, if we go for the higher powers like a raised to power 5 minus b raised to power 5 or a raised to power 6 minus b raised to power 6 and so on, we will find that a minus b will always be a factor. So if we generalize this, we can say that a raised to power n minus b raised to power n will always have a factor of a minus b for all natural values of n. But when the powers of a and b are even, then only it has a factor of a plus b. For example, a square minus b square has a factor of a plus b, but a cube minus b cube doesn't have a factor of a plus b. In a similar way, a raised to power 4 minus b raised to power 4 has a factor of a plus b, as the power here is even. And in a similar way for the higher powers as well. So we can say that a raised to power n minus b raised to power n will have a factor of a plus b only when this small n belongs to even natural numbers. So a raised to power n minus b raised to power n will always have a factor of a minus b irrespective n is an even or odd natural number, whereas a raised to power n minus b raised to power n will have a factor of a plus b only when n is an even natural number. For example, if I take this number 21 raised to power 86 minus 12 raised to power 86. So this number is of the form of a raised to power n minus b raised to power n, where n is an even natural number. So this will have a factor of 21 minus 12, that is a factor of 9. So that means this number would be completely divisible by 9. In a similar way, here the power is an even natural number. So this number will also have a factor of 21 plus 12, that is a factor of 33. So we can also say that this number would be completely divisible by 33 as well. In a similar way, if a number is of the form of a raised to power n plus b raised to power n, we'll find that it will have a factor of a plus b only when n is an odd natural number. For example, if we take this number 21 raised to power 37 plus 12 raised to power 37. So this number is of the form of a raised to power n plus b raised to power n, and here the power is an odd natural number. So this number will have a factor of a plus b, that is a factor of 21 plus 12, that is 33. So we can say that this number will be completely divisible by 33. So a raised to power n minus b raised to power n always has a factor of a minus b irrespective n is an even or odd natural number, and it has a factor of a plus b only when n is an even natural number. Whereas a raised to power n plus b raised to power n has a factor of a plus b only when n is an odd natural number. Also, there are formulas for a raised to power n minus b raised to power n and a raised to power n plus b raised to power n, which is given by a raised to power n minus b raised to power n is a minus b times of a raised to power n minus 1 plus a raised to power n minus 2 times of b plus and so on till b raised to power n minus 1, where n belongs to natural numbers. And a raised to power n plus b raised to power n is given by a plus b times of a raised to power n minus 1 minus a raised to power n minus 2 times of b plus and so on till b raised to power n minus 1. And this formula is valid only for n belongs to odd natural numbers. Well, this part is very important, which we need to remember to solve questions involving numbers in the form of a raised to power n minus b raised to power n and a raised to power n plus b raised to power n. But I would also suggest you to remember the structure of these formulas, as sometimes we can use it directly to find the solution. So that's it for today's video, in which we have seen some of the algebraic formulas and rules pertaining to numbers which are in the form of a raised to power n plus minus b raised to power n. And in the next video, we'll be doing some problems based on these formulas and rules. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I will see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.